Yeah. So if I plug in -4 into that, what do I get? -1 over -8, which is 1/8. 1/8, which is just up a little bit, right? Just right here. Now plug in -2. -2 plus 3 over -2 minus 4. You should get 1 over -6, which is -1/6, which moves it down. So right here at -2, I come down a little bit. One more test point. 7 plus 3 over 7 minus 4 is 10 over 3? 3.33? 3333 forever? So at 7, I'm at 1, 2, 3.3, somewhere around there. Got it? Any questions? This is everything we need to draw it. Yes. Okay, so let's look at this one right here. -4, 1/8. That means when I plug in -4, I get 1/8 out, right? This is your x and your y coordinate. X is -4, 1, 2, 3, 4. Y is 1/8, go up 1/8. Got it? Everyone got that? That's all you need. The last thing, we go back to like kindergarten and we connect the dots. But you have to think. It's a little bit more than just being in kindergarten here. You have to think about what's happening. You are never allowed to cross this, and you must draw your picture, and it must get pulled towards the magnets at the edges. All right? There's a little bit of thinking you have to do here. So I always like to start at the leftmost point that I actually know exists on my graph, which is that one right there. And I imagine, what do I have to do as I draw out to the left? What do I have to do? Go up towards that magnet, right? So I'm going to have to go up towards this magnetic green line, and it's going to approach that asymptotically. That's good. I mean, if you just do that with a little arrow, I understand that you're just getting closer without touching. That acceptable? Now, at this same point, as I draw to the right, I'm going to have to get to this point, right? So it seems natural that it would just connect. And then I have to get to this point, which means I must pass through like that, right? And then where do I go from there? Towards this, right? This is the only thing in my way. So I'm driving down the road here, and I'm going to hit that wall, so I have to avoid it. So which way am I going to go? Down. Why not up? Why not do this? Don't draw this, but why not do this and then say, there's a wall, I'm going to go this way instead. Why not do that? What's that? I'm sorry. Everyone's like, Because my point's already down, so stay down. One. No, up here, no, you can't. That's why we only draw it at the edges. It will, yes, but why do I know that for sure? What tells me that this can't do this? Exactly. If I went up, I create an x-intercept that doesn't exist. Do you see that? That's the key. So you must stay down, and that means you must turn downward. Now, I understand that it just looks like it's going to do that, right? It just kind of looks like, yeah, that's what it's going to do. But the reason why it can't turn up is because you would create an x-intercept that doesn't exist. So it must go down forever, like this. Very good, Lena. All right. Have to pick up my pencil, right? At this point, pick up my pencil. I go to the next point right here, and I have to think about the same thing. What would I have to do if I went out to the left? I've got the barrier, so I've got to go up to avoid it or down to avoid it. Up, why not down? I would create an x-intercept, right? If I do that, I've got to cross the x-axis. So I'm not allowed to create a new x-intercept, so I have to go up. So that has to go up, and then what happens is I go out the right side. This way. Got to go towards that magnetic green thing, right? So it's going to be hard for me to draw this, but it's going to go like this. And then up here it's going to take off. And I'm out of room, but I would extend that up and just kind of arc it in. And there's your graph. It's a lot of work, right? Are there any questions? Yes?
Are there any steps after that?
That's it. Nope, you're done.
Are we going to go over the other two pieces?
Yes, but do you want to take a break first? 10 minutes. Let's say it's 1:51. Let's go. Let's come back at 2. All right, that's a 9-minute break. The homework for tonight, I'm going to give you at the end of class. No homework out of the packet. Okay? It'll be just like last time. I will sign it and you can turn it in. All right? We ready for another example? All right. I know, you sound thrilled. Okay, example. Sketch f of x equals 2x minus 8 over x squared x squared minus 6x. Step one, what are you looking at? Rational function. It's rational. Step two. X-intercepts. You know what? Let's see if you can find the x-intercepts and you can find the vertical asymptotes. Those two things you should be able to do on your own right now. See if you can do that. Passing around the sign-in sheet. You know how to find the x-intercepts? Okay. Set the top to 0, right? Yeah, okay. And work on the bottom. When you have both of them, raise your hand. That way I can get a feel for where everyone is. Okay. Good? What's up? Oh. Where's there's a what?
A line here, right here.
I don't know. They weren't signed, so.
Well, I mean, I only missed one day in class, which was Monday.
I have no idea. Just sign it.
Sign it?
Yeah, it's fine. I'm not worried about you. It's just I have to keep track of it.
Yeah.
And that way, if someone like disappeared, I can say, yeah, they weren't here, or, you know. But sign in on today's date.
August 1st.
Yeah.
Oh, August 2nd.
Yeah. Okay, are we all there? Okay, so on the x-intercepts, you set the top to 0. That's a linear equation. It's pretty straightforward. On the second one, it's a quadratic equation. GCF? See the GCF? What's the GCF? X. You pull an x out, x minus 6. You set both of those equal to 0. So what are the two vertical asymptotes? 0 and 6. Okay, we have two solutions there. Fourth step. What's the fourth step? Horizontal asymptotes, right? Is this case A? This is not case A. So I told you I would add to the cases. So what's case B? Well, case B is the degree of the numerator is less than denominator. That's the case we have now, right? What's the degree of the numerator? 1. What's the degree of the denominator? 2. Is the degree of the numerator less than, smaller than the degree of the denominator? Yes. Okay? So this is the case we had. In this case, y equals 0 is the horizontal asymptote. So remember last time we had to look at the numbers in front? Remember that? We do not have to do that here. There's actually no work that has to be done. It's y equals 0. Now, what's another way of saying y equals 0? Up and down, y is 0. Isn't that the same as the x-axis? Isn't that the x-axis? This is the x-axis. But your ends only, remember we're just going to dot it at the ends because it's a horizontal. So for us, in this problem, it's case B, so y equals 0. And I move on. What's step 5? Plot the information and do your test points. What's the first piece of information I'm going to put on here? X-intercept of 4, which is going to be what on my picture? A what? A point? Where is it? On the x-axis. Right here at 4, I have a point, right? Next thing I'm going to plot. Step 3 was vertical asymptotes. These are going to be what on my graph? Dotted vertical lines. Now, you're going to have a little bit of an issue because the x equals 6, that's kind of easy to do, right? Like here's 5, here's 6. It's pretty easy to draw a dotted line like this, right? But the other dotted line needs to be at 0. And you already have a solid line, don't you? So it's kind of hard to draw a dotted line on top of a solid line. So what my students have done in the past is instead of doing dotted, they do like dashes but a little diagonal so you can actually see the vertical asymptote there. Does that help a little bit? What other information do I have? Horizontal asymptote. Y equals 0, which is the same as the x-axis. I draw these as dotted lines horizontally at the edges only, right? So I'm going to give myself some room here. I think to the right side on my graph, it'll be pretty easy to draw a dotted line. I just need to make sure I'm on the right side of the last piece of information I have, which is this. I'm going to just go over here and draw dotted. And then over here, the last piece of information I have on the left side is this dotted one. So I'm kind of going to erase this x-axis, make it a little shorter, and just do like that. Understand? I'm not going all the way across with that, for sure. Now what do you need? By the way, this is step 5. Everything I'm doing right here is step 5, and it's the final step. Test points. Can anybody tell me how many test points I'm going to have? 4. How are you figuring that out? You have 2 vertical asymptotes and 1 x-intercept, so that's 3 total. 1 more than that is 4. So you should have 4. I haven't been calling on anyone. Been a while. So let's see, who's going to be my brave soul? Who wants to volunteer? Go ahead, give me one of the test points.
I still go with decimals. Okay, we'll go with 1.
You want to do 1? Everyone okay with that? 1? All right, somebody else, give me another test point. 5, good. Notice that I gave you a problem on purpose that left a number in here that was easy to grab. Like if this was 4 and that was 5, you would have to pick a decimal. But I left it to be a nice number in there for you. 5. Okay, that works. Somebody else? Remember, I'm putting little X's, not dots. I could do 3, but the problem with doing 3 is that I already have, see, you're supposed to go to your vertical and get something to the left and to the right. I already have something to the right, right? If I go to this x-intercept, I need something to the left and to the right. I already have something to the left, and I have something to the right. See that? Go to this one, left and to the right. I have something to the left. I need something to the right. So, what? 7. I can do 7. I'm still missing 1. -1. Right? Because I didn't have 1 on the left side of this one. Understand? Plug those in. Please keep in mind, you may have different test points than other people in the class, but we should all get the same general picture at the end. So I'm going to plug in 1 into the function, which I erased. I think that was it. Yes, that was it. So I'm going to plug in 1. I get -2 on top. I get -5 on the bottom. I get 2/5. So 0.4. Anyone else get 0.4 when they plugged in 1? Negative. It's 0.4.
2x minus 8.
Oh, it's 2x minus 8. Sorry. It's 0.4, but I wrote the wrong damn problem down. Okay. Sorry. What does that change it to? -6 on top. Is that right? 2 minus 8 is -6 over... So what do you get? 1.2? 1.2? So where's that point I'm going to draw? X coordinate is what? 1. Y coordinate, 1.2, up, right? So I'm going to be like up here somewhere. Plug in 5 now. Let's see what you get. 10 minus 8 over 25 minus 30. 2 over -5? -0.4. Questions? Plug in 7. 14, take away 8, 6. 49, take away 42, 7, 6 sevenths, which is almost 1. So it's going to be up here somewhere. These don't have to be perfect. In fact, really at the end of the day, all you really want to know with the test points is whether or not you're above or below the x-axis. That's all that really matters. So how high you put it, don't worry. And because of the order we went in, I'm going to go back and do -1 now. So you get what? -10 over 7? So it's -1 point something, so I'm down here. Pardon? But it's negative, right? Okay. I'm getting some glossy, glary looks. Is everyone following this? All right, so if you have already answered any of my questions today, you are not allowed to answer the questions that I'm about to ask. So I'm only taking volunteers from the people who have not participated. So who would like to be my first volunteer to tell me what I'm going to do when I'm drawing to the left of this point? It has to be someone who hasn't responded. Who's my volunteer? From this point to the left. Raise your hand, or I'll call on you. Daniela, that's right. Okay.
So go up.
2. Like that? Oh. Like, okay, towards the green dotted line?
Yeah.
Okay. Good. Somebody else to tell me what I do out the right side of that.
Down towards the right.
Down towards the red. And why can't I go up? I'll create another x-intercept, right? Okay, who's up next? I have to pick up my pencil and go where? I'm looking for volunteer. Go ahead. Justin? Go from where? This point right here? From this point to the left, what do I do? No, I want to go out to the left. I have to draw this thing to the left and to the right. So if I draw it to the left, what has to happen? I have to go up, right? That barrier forces me up. I can't go down because I'll have to cross the x-axis. Okay, someone else out the right side. Mom? 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 If I'm drawing this out the right, just connecting the dots, that's it.
Dot to dot.
That's right, dot to dot. There's nothing in my way, right? I just dot to dot, and now I have a problem, Mom. So what? Here's the wall. Don't hit it. Don't cross it. Walls do what to you? They force you up or down. That's it. So which one is it? Down? That's it. You can't turn back up here because you're not allowed to cross the x-axis again. And you can't do anything crazy like this either. Can't turn around. Yeah, so this last point. So who's up? What's up? Do you want to do? You look like you're having a rough day. Are you all right?
Yeah, I'm so
You don't feel good? Okay. Then I won't bother you. It's okay? Okay, then I'll bother you. So at this point, can you help? Because
You're just gonna go up without touching
this one? Okay, so towards that, like that, and then out the right?
go down.
Down. Okay, that's it. Just that. So out the left side. So when you're doing this, think about every dot you have to go out the left and the right. For every dot, you have to figure out what happens to the left and to the right. That's it. It's the graph. I'm done. All right, we have 20 more minutes. And I think what I'm going to do is just not give you case C. Just not. We're just going to say we aren't even going to deal with case C. All right? Sound okay with you? Case C is if the degree of the top's bigger than the bottom. And I will avoid those completely. Not because they're harder, just because of time. And we do need to get to exponential functions. And we can start that tomorrow. So what I'm going to do is I'm going to put up some problems for you to do for homework. And we're going to call it a day. I don't have enough time to do the case C. I'll run out of time. Okay? So I'll give you problems to take home, and we'll end a little early. Okay, so for homework / quiz to turn in next time, sketch all of these. That'll be an interesting one right there. I think that's good. 2 and 3 are similar, but your graphs are going to look completely different because I've flipped which is the numerator and which is the denominator. So all your x-intercepts become vertical asymptotes and all your verticals become x-intercepts, and it changes the way things look. Okay? All right, 3 problems. That, each one of those should probably take 20 minutes or so, maybe. I don't know. It'll depend on you. Have a great day. Yes.
Do you want to tell me what this H3 is?
Yeah, I'll tell you.